Here we go. Okay. So to find the instantaneous rate of change right at 10 minutes, I had to find the derivative, because the derivative is the rate of change at a single point. And then once I found the formula for the derivative, I simply substituted in 10 minutes, and it gave me that is 8,000 gallons per minute that it was flowing out at exactly 10 minutes. Then the other part of the question is, well, how fast is it flowing out over the first 10 minutes on average? So I want to average out how fast was it coming out at the instant that I started, all over the 10 minutes that I was running the water. I'm gonna do a little tangent here, okay, and try and make a different kind of analogy that might help it become more clear. And we did this before, but here I am at minute 0, and here I am after 5 hours, and I am going the 450 miles to San Francisco. Okay, right? And I start here and I end there. So my average rate of speed, right? Well, I went 450 miles in 5 hours. So my average rate of speed was well, 90 miles per hour. Everybody follow that? Right? That's because I took my rate of speed at the end here. I took how far I went over the 450 miles, and I started at 0. So, and I divided it by the 5 hours. Did I go 90 miles per hour from the second I started until the second I got to San Francisco? No, I only went 90 miles an hour when I was on Highway 5 and there were no cops, right? I was when I'm going in the city of LA and I'm going up La Brea to get to the Hollywood freeway, no, I'm not going 90 miles an hour. I'm taking it nice and slow, okay? So my instantaneous rate of speed, you know, it might have looked something like that. I don't know, you know. And at this particular moment, I was going that fast. And that particular moment, I was going that fast. So if I go back to my water tank here, if I want to know the average rate that the water was coming out, I look at, well, what rate, how much water did I start with? And how much water did I end with? And what was the time that this took? It was 10 minutes. And I take 180 minus 80,000. I used 100,000 gallons in 10 minutes. That's 10,000 gallons per minute on average. Does that make it a little bit more clear? Kendra, is that a little bit more clear? Everybody else, are we good with that? On average, I take the beginning point, the ending point, and then I subtract, you know, the difference there. We're okay with this. That would be the average. Now, I'm going to ask a question. Why is the average, and then this is like more of a physics question, but like, why is the average over the 10 minutes so much higher than the instantaneous rate at 10 minutes? So kind of just try and visualize what's going on with this tank. Why is the average so much higher over the full 10 minutes than it is instantly at 10 minutes? Think back to the example that I was gonna like go get something and illustrate it for you, but I didn't want to get my computer wet. All right, let me ask a different question here. All right, I'm going to ask Natalie. Natalie, if I have a full tank of water, is the water going to be coming out fastest or slowest when the tank is full?
Fastest.
I think so, because I got, you know, how many hundreds of thousands of gallons of water there. all pushing down on this opening at the bottom, right? But when I get down to the very bottom, I'm at the last drips, right? Is the water coming out faster or slower?
Probably slower.
That'd be a whole lot slower, right? I mean, if this tank is emptying out, by the time I get to the bottom, I mean, it's really drip, drip, drip. Whereas when the tank is full, it's like coming out like a fire hose. I mean, you know, it's like really coming out fast, right? So the rate at which the water is coming out of the tank is decreasing as the tank gets lower and lower and lower. Does that make logical sense to you? A little bit? All right, let's do one more thing to kind of show that in reality. Okay, it says 230 minus t squared. So I'm going to go back to Desmos, and I'm going to say f of x is equal to 200 times 30 minus x squared. Okay, now we can't see it because it's probably like really big. Let's see what we got. It looks like here. I'm going to zoom out a whole bunch. Yeah, it's over here. Okay, it's this nice parabola here. It's a parabola because it's squared, right? And so this is what we would be looking at. But I want to draw, what's the derivative of this going to look like? I'm going to ask that as a question. What's the derivative of this going to look like? What kind of a shape is it going to be?
Just a line because it's like one power lower.
That's right. This is a quadratic. It's going to be to the first power. Anything to the first power is going to be a line. So I'm going to go g of x is equal to d dx of f of x. I need to adjust this a little bit here. So let's go from like 25 to 35 and see what happens. Oh, you know, it's never mind. Forget it. I don't want to go there. All right, we'll rewind, delete. When you get this on the no, I don't. Yeah, when you get this on the my screen's still being shared or no? It is. That's funny. Huh. I want to stop. I want to pause the recording.